Welcome back to Air Quality Matters. And my take on a paper or report on air quality, ventilation and the built environment. One take in that it's, in one take and tries to summarise for you a scientific perspective on something interesting in, usually 10 minutes or less, because who has the time to read all these amazing documents, right? This week, we're diving into a really fascinating paper published in the Journal of Building and Environment, and it's called A Method for Testing the Gas Phase Air Cleaners Using Sensory Assessment of Air Quality. This was put together by Cantor Amada, Fang, Pavel Wargocki, and a few others from Waseda University in Japan and the Technical University of Denmark. And I really like this one because it gets right under the hood of how we actually approach a specific scientific question in our sector. How do we know if an air cleaner, for example, is actually doing its job? And more importantly, how do we assess it properly? Let's set the scene a little bit. We know that building energy use accounts for a massive chunk, about 40% of global energy use. In the tertiary or commercial sector, ventilation, heating and air conditioning use almost half of all of that energy. So naturally, everybody's looking for ways to reduce that energy consumption while still keeping people healthy, because let's face it, we spend about 90% of our time indoors and all that. One of the major strategies being explored right now is using gas phase air cleaners to supplement or even replace some of that outdoor air ventilation. The idea is simple here. If the air cleaner removes the gaseous pollutants, you don't need to bring as much outside air in to dilute them, saving you significant energy in the process. But here's where we get into, the challenges of all of this. How do the current standards tell us to test these gas phase air cleaners? Well, they generally tell you to challenge the air cleaner with a few specific selected chemicals. So you might measure how well it removes formaldehyde, for example. But indoor air is incredibly complex. It contains literally hundreds of different gaseous pollutants in any scenario. If you just use chemical analysis and a handful of compounds, you might completely underestimate the real-world performance of that air cleaner. Or, and this is the really concerning part, you might completely miss the harmful byproducts the air cleaner is actually creating. Some technologies, particularly what the authors call additive air cleaners, which decompose chemicals by active components like photocatalytic oxidation or ion generators or even UV and ozone type devices, can actually transform relatively harmful pollutants into less harmful or even dangerous unwanted species, or pump ozone into the space, a chemical generator all of its own. If your standard chemical test isn't looking for those specific byproducts, the machine gets a pass grade while actively making the room worse. So the research team, as part of the IEA Energy in Buildings and Communities Annex 78 project, proposed examining prototype testing method based on something a little bit more old school and perhaps far more comprehensive, the human nose. People have been using human panels to measure perceived air quality since the 1930s, and it's built right into our major ventilation standards like ASHRAE 62.1 as an example. They set up these experimental field laboratories, essentially highly controlled rooms at the Technical University of Denmark, and tested different types of portable air cleaners. They broadly categorized them into two types: subtractive air cleaners, which remove chemicals using things like activated carbon, and additive air cleaners. To make it realistic, they didn't just pump in pure test gas. They used actual building materials, old carpets and linoleum. They used real human beings sitting behind partitions to generate human bioeffluents. Then they had around 30 recruited panelists evaluating the air quality. They structured the testing into two phases, and I think this is the really smart, practical approach. Phase one is basically a screening phase. The whole point of phase one is just to make sure that the air cleaner doesn't have a negative effect on the air quality. Do no harm. And I'll be honest with you, the results here were a little bit eye-opening. Let's look at those additive air cleaners, for example. The UV ozone device, which they called PAC3A, actually increased the odour intensity in the room, particularly when humans were present. So the researchers rightly dropped it. It wasn't even included in phase 2. But interestingly, they did allow one additive cleaner through to the next round, the ion generator, called PAC1A. Didn't have a positive effect on air quality in phase 1, but they included it in phase 2 anyway, just to see if those poor results would be repeated. Spoiler alert, they were. It significantly decreased the acceptability of the air in phase 2 as well. Phase 2 was the deep dive. They took the subtractive air cleaners, the activated carbon ones, along with that ion generator, and tested them at various different ventilation rates, from very low 2.5 litres per second per person up to about 10 litres a second per person. The panelists would walk in, take a breath, and rate the acceptability of the odour intensity. They also had diffusers extracting air into the corridor for what they called facial exposures, where people just stuck their face in the airstream. Here is where we get the big so what of the paper, I think. When the pollution source was purely building materials, the activated carbon air cleaners did a fantastic job. They significantly improved the acceptability of the air quality. But when the pollutant source was humans, people just sitting there breathing and existing, the air cleaners did not significantly improve the perceived air quality. Now, why is that so significant? Well, in phase 2, they didn't just use human noses. They ran parallel chemical measurements using Annex TA tubes and gas chromatography mass spectrometry. When you look at the chemical data, the total volatile organic compounds, or VOCs, drop significantly when using the carbon air cleaners, regardless of whether the pollutant came from materials or humans. If you were only looking at the chemical spreadsheet, you would say, brilliant, the air cleaners worked perfectly in all scenarios. But the human panelists were telling a completely different story. The chemical measurements simply did not match the sensory evaluations. The chemical tests showed lower VOCs, sure, but they couldn't tell the researchers which specific pollutants were actually driving the bad smells or feelings of stuffiness for the occupants. This is a massive point for anyone involved in managing buildings, I think, writing specifications or trying to achieve energy efficiency credits. You cannot rely on chemical analysis alone to characterize how an air cleaner is going to affect the people in the room. If your goal is to have productive, comfortable occupants, and you're trying to substitute your outdoor air ventilation with an air cleaner, you absolutely must include sensory testing. The authors point out that this research heavily supports the new ISO 16000-44 standard that was approved in 2023. That standard actually outlines the test method for measuring perceived indoor air quality to test the performance of these gas phase cleaners. So we are slowly moving in a direction where the sector recognises that the human experience is a metric. Of course, as with any study, there are a few limitations. The authors note that the results comparing additive and subtractive cleaners shouldn't necessarily be universally generalised, as they only tested a few specific units. They also noticed some unexplained differences between having a panelist standing in the room versus smelling the air through a diffuser, which needs more investigation. And they haven't yet calculated the sensory-based clean air delivery rates in this particular paper, though they plan to release those calculations in future publications. But the core takeaway, I think, is rock solid. If we're going to rely on technology to clean our indoor air and save energy, we need a testing protocol that weeds out the bad performers that actually make things worse, firstly. And we have to remember that a gas sensing piece of equipment doesn't get a headache or feel stuffy. People do. Until we have a chemical test that perfectly mimics human perception, the human nose has to remain a fundamental part of how we validate these systems, even if it does seem a little bit old school. Thanks as always for tuning into this week's One Take. These podcasts are not possible without our sponsors, Safe Traces and Imbiot, so thanks a million to them. Please do tune in again next week.